Hey Andrew, so the major thing that you missed while you were out last week was the graphs of the polar equations. So one thing I need you to do is study that red piece of paper that I gave you yesterday and come to me with any questions that you have about any of those graphs. They're also in your unit packet. So you're going to need to be able to identify equations as falling into one of those categories on the quiz that you missed. The other thing was something that we alluded to yesterday, but that I wanted to give you a more concrete foundation about in this video. So these transformation equations that you saw yesterday are going to be foundational for the remainder of the unit. So in order to develop them, what we did the other day was looked at a polar point somewhere on a polar grid, and we drew a right triangle out of that point. And forgive me, my stylus is not great, but there's a right triangle living in the polar grid over here. So we talked about how in trigonometry, if there's an angle down here, and the labeling of these, oh goodness, hold on. The labeling of these sides is like it used to be with an X down here, a Y over here, and an R over here, that based on prior knowledge, then cosine of that angle, this is old news I hope, would be defined as X over R, sine of that angle would be defined as Y over R, and tangent of that angle would be defined as Y over X. Additionally, using Pythagorean theorem, X squared plus Y squared would have to be equal to R squared. So this entire column was just stuff back from Unit 4 that you had already learned. And so what we did then was manipulated these equations a little bit to solve for things that are a little bit more interesting to us now that we're in Unit 8. For example, if I wanted to solve this cosine equation for x, the major manipulation that would need to happen is to multiply both sides by r. And I would get a resulting equation of x equals r cosine of theta. And this is going to be what we really use moving forward. Additionally, y would equal r sine of theta. Theta would actually equal, this one was a little interesting, we had to have a conversation about how to cancel a tangent, and your peers finally remembered that tangent inverse is what will cancel that tangent. So theta would equal tangent inverse of y over x. And finally, r would just equal the square root of x squared plus y squared. So using those relationships, we're then able to convert between polar and rectangular coordinates. And this model problem I'm pulling straight from page 22 on your unit packet. But what we talked about then was if ever you're asked to get rectangular coordinates given polar coordinates, those transformation equations can help us out. So in this example, the point P is 4 pi over 6, which means my r is associated with that 4, and my theta is associated with that pi over 6. So if I want rectangular coordinates, then what I'm thinking here is that the goal I'm trying to achieve is to get a point in x comma y. And according to those transformation equations, that means I'm looking for an r cosine of theta, comma r sine of theta, since those were the transformation equations that defined x and y. And looking at my annotation over here, I know what r is and I know what theta is, so this just becomes an evaluation problem. I'll plug in a 4 for r and a pi over 6 for theta. And similarly, I'll do the same thing for my second coordinate. And then this becomes an assessment of an old skill called our unit circle. So we did have to remind ourselves about the angles in quadrant 1 of that unit circle. Pi over 6 is this first one, 30 degrees. And the coordinate point is square root of 3 over 2 comma 1/2. And you can go back in your notes and review that if you need to. But that means this becomes 4 times the cosine of pi over 6, and we did do, like some annotation and reminding ourselves that that's the x, this is the y, this is the x, this is the y, so that we were able to confidently claim that the cosine of pi over 6 would be square root of 3 over 2. The sine of pi over 6 would be the 1/2. Then doing a little bit of multiplication, I get 4 square root of 3 over 2, comma 4 halves, or 2 square roots of 3, 2. And this is how we talked about converting from a polar point into a rectangular point. I believe that you were here yesterday to get a recap on how to go the other way, given a rectangular finding a polar, and so that's in your notes. And then, like I said earlier, the other major skill that you missed was being able to identify the graphs of polar curves. So what I'd like for you to do is see if you can navigate through most of problem set 4 now after this video in today's class period, and also be studying that red piece of paper. Excuse me, sorry. My goal is that you will be able to do a matching activity that really assesses the families of curves on the red sheet, and then be able to take your quiz this week, and then we can schedule your unit exam for next week, so we can give you the weekend to kind of synthesize everything and get yourself caught up. I would like to talk to you about what you can do for me on Thursday while the rest of your peers are testing. I'm going to ask a big favor of you. But anyway, please let me know if you have any questions, and I hope that this video helped you out.